Okay, we're now going to work through one of the WJC's other scenarios. Now, if you've got my pack here, you'll find it in the other scenarios folder. These are scenarios that the WJEC have given to us on training events, and I hope that these are sort of indicative of the sort of things that we can expect to see over the next couple of years. Most of them are absolutely bog standard, but there are one or two that are quite interesting. I want to start today with the Ocean 11 scenario. I've already opened that up here, and I've got the questions here. Now, what's interesting about this scenario is that there are now two characters that can be controlled by the user. So let's start off. We've done task 1 and opened the scenario. And task 2, populate the world with a boy, a girl, some grumpy fish, some happy fish, and a lighthouse. Let's get started doing that. So we need, let's have a look, a boy. We need a girl. We need some grumpy fish, and some usually means more than one. Let's put 2 in. Don't forget, when you get your actual exam papers, there'll be a picture at the bottom that shows you what it should look like. Copy that as much as you possibly can. 2 happy fish there, and a single lighthouse. There we go. So we've got everything we need in that world, which means I'm going to right click and save it, which pops up the code just to show you that's happened. But what we want is, for whenever we reset it or compile it, we want that entire window to come back up. So question 3, edit the boy so he moves when you hit the arrow keys. Okay, so we're going to get the code for the boy, and as ever we are dealing with the code in the at space, and we are going to need an if statement. We are going to need to use the Greenfoot library as well, and what we'll be looking at is is key down, if I can spell. And remember, the is key down library, the point of it is that what it does is it looks to see if you've pressed a key. It's not looking to see if you've pressed a certain key down. So let's start with up. Now I'm going to put some curly braces here, because the way Java works, of course, is that the curly braces tell me what's going to actually be executed in terms of code once I've done. I've missed a speech mark there, I'm sorry. Once I've matched the if statement. Now, first of all, the boy is just being asked to move. Normally they ask you to rotate and move, so we'll do both. And what we need to do is we need to set rotation. Now, I like set rotation rather than just turn, which is another option. But set rotation lets us put the exact rotation compared to its default position. So my boy, his default position is head is up. So if I want him to go up, I'm not going to rotate him at all. I'm going to leave him where he is, rotate him at 0 degrees. I'm then going to move him, and I'm going to move him using set location. Set location has 2 arguments. It has the x and the y coordinates of where you want to move him to. So let's move him to the current x position and the current y position that he's already in. So this doesn't move him anywhere at the moment. So let's have a think about that. If he is moving up, I would need to move him in the y-axis. Now, interestingly, the way the computers measure distance is from the top left pixel in your screen, so over here. So if I'm going up, I'm actually taking away and minusing 1 from the y-axis. So let's do that there. And let's check that works by compiling it, by clicking here and running it. And just checking that if I press up, my boy moves up, which he does. Fantastic. So back in our code now, let's take that and copy it, and we're going to paste it 3 more times. We're going to deal with down. So down is the opposite direction. So it's going to be 180 degrees, i.e. pointed downwards. And we're going to add 1 to the y-axis. The next one we'll do is right. Why not? And now there's no movement in the y-axis for right, but we are going to add 1 to the x-axis. It's moving away from the top left corner. And the rotation, if I'm turning right, so I'm turning my boy to point this way, is going to be 90 degrees. Finally, we'll do left. And of course, all that's left is 270 degrees, i.e. pointed left, and we are going to be taking one away from the x-axis. Let's compile that and let's check this works. We'll click run, up, down, left, right, and the boy is pointing in the right direction. Fantastic. So we have completed task 3. Task 4 is now quite exciting. For those gamers of you in the audience, you'll know that WASD is a common directional control layout on a normal keyboard. And that's what we're going to do. We're going to program the girls that she moves WASD. Now, the easiest thing for this is we've just spent all our time programming the boy to move. So let's copy that. And let's paste that into our girl code. There we go. This time, though, it's not up, down, left, and right. It's going to be W, S, D, and A. Compile it and run it, and we should find that WASD moves the girl in those directions, and I can now move both characters independently. So that completes question 4. Question 5, edit both sets of fish so that they move randomly, is now our next step. So let's start with our grumpy fish because he happens to be there. And what I'm going to do is I'm actually going to paste in the code that we've just written for our manual movements. But of course, I don't care about the button presses this time. So we are going to go through and change those if statements. What we need to do is we need to randomly select a direction to go in. So we need to tell the computer which direction that is. Java is a strictly typed language. That means we have to tell it it's an integer. We need to give it a name. I'm going to call mine direction. And I'm going to set it to Greenfoot's random number generator. So Greenfoot.get random number. And the nice thing about Java is that all of the methods are written nicely in camel case. Now, we need to give it a number. We need to give it the amount of directions that I can choose from. There are 4 directions to choose from, up, down, left, and right. However, the numbers I'll get will be 0, 1, 2, and 3, because this will give us a 0 index number, i.e. a number starting from 0. So, instead of up now, being that, we change our if statement to read if the direction is equal to 0. Then we will go up. Down will be 1. And it really doesn't matter what order you do these numbers in, as long as it's something logical. So 2 there. And 3. Compile it, check it works. And if we run it, we should see the grumpy fish moving around. Now, I think I've got the angles for those guys wrong. If I reset my grumpy fish, they are starting to the right-hand side. So actually, if they're going right, which is this one, they wouldn't move. Sorry, right is this one, isn't it? Yeah, sorry, if they're going right, they're not going to move. That means if they're going left, they're going 180 degrees. If they go up, they're doing 270. And if they're going down, they're doing the 90-degree turn. And this is just from where they are oriented. Because the fish is pointed to the right, turning in 90 degrees, and it's always moving it to the right. 90 degrees to the right, pointed down that way. 270 degrees, point it up this way. And 180 degrees, point it that way. Let's just compile that and run that. Now, realistically, because of the random movements, you're not going to notice if they're going the right way or not. I can tell because I've done a lot of these, and I imagine that the assessors notice as well. This question doesn't specifically say to rotate them, but a lot of them do. Now that code works for the grumpy fish, let's put it in the happy fish. There you go, happy fish. In the act method, remember the act method is the bit that just tells it what to do every frame. And if we run that now, there we go, everyone's moving around and they're very happy. We also need to edit the lighthouse so it moves randomly. And the lighthouse, annoyingly, is in the same orientation as the boy and girl. So when we paste the code in, we're going to have to change the rotation values back to what they were. So it's pointed up, so up will be 0, down will be 180 because we're turning it in the opposite direction. Right is going to be 90, and left is going to be 270. Oh dear, I managed to put a million things in that box instead of just the one. Yeah. Now, you remember the semicolons at the end of each line are because they function as if they were full stops in the English language. There we go. Everyone's moving around in the right direction now, and we control our main characters. Okay, edit both people. So when they hit the lighthouse, they disappear. And this is a bit of fun. When you have to make something disappear, you always put the code on the object that doesn't disappear in the collision. So because the people are disappearing, I'm going to edit the lighthouse. So the code here allows it to disappear. There's a number of different things that I have to do here to get this to work. My first job is that I have to sort of introduce my lighthouse to the characters that it could encounter. So I'm going to start with, I'm just underneath the method I've just written for movement. I've got actors that I want to introduce you to. There's going to be a boy and a girl. Now, this sort of format of putting a comma between them allows me to talk about more than one actor at once. I could just have two different lines, actor boy and actor girl, if I wanted to. This just saves me a little bit of time. The next thing I'm going to do is tell the computer about the individual boy that I might be overlapping. So the boy is equal to get object at offset. And the way this function works is it tells me, it says, is there anything overlapping me by this many, I suppose, boxes in the left and right direction in the X and Y axis? So is there anything overlapping me on top 0, 0? And the third argument needs to be the type of thing it is. So this is a class dot boy because that's the type of thing it is. So is there a boy overlapping the lighthouse? And if it is, it's going to be called boy. I'm going to do exactly the same thing for the girl as well. Is there a girl overlapping the lighthouse? Oh dear, excuse me. Is there a girl overlapping the lighthouse, and is it of type girl? Before we get into any if statements, we also need to tell the computer about the world we live in. So our world is called Ocean 11, so that type of thing, an Ocean 11. Let's give it a name, so I'm going to call mine Ocean, equals brackets Ocean 11, space, get world. Now this is a little bit complicated to explain. What we're doing here is we're making a link to an Ocean 11, i.e. our world, called Ocean. And that is going to be the world we're currently in. That's what get world does. However, the problem is get world returns a world. And that's going to shout at us. What this bit in brackets is casting. In the same way that in other programming language we cast ints as floats and vice versa, and strings as ints when we take them in from the command line, this tells us that the type of world that we're dealing with is an Ocean 11 world. And that will work nicely just to give the lighthouse, in this case, an understanding of any boys that might be overlapping it, any girls that might be overlapping it, and the world that we currently exist within. With everything set up, with all the introductions done, we can start deciding what's going to happen. So we start with if the boy is not equal to null. Now what that means is if the boy is on top of the lighthouse, the boy will have a value. The boy will have some information in it. If the boy is not on top of the lighthouse, there will be an absence of a boy. And the absence of data in a computer is called null. So what this if statement is saying is basically, if there's a boy on top of the lighthouse. Well, what are we going to do? Well, we're going to talk to the world we're in, which we called Ocean here. And we're going to tell it to remove an object from itself. And we're going to remove the boy. We're going to have a second one after that, which does exactly the same thing, but with the girl. Just replace boy with girl there. And compile, and we should be okay. This is shouting at me. Legal stance of expression. What have I done then? What naughty thing have I done? Get object offset. Oh, sorry. Get one object at offset. Here we go. Still doesn't like me. Boy.class. I do apologize. There we go. And of course, the girl should be capital G because it's the same as elsewhere. There we go. Now let's run it and just check this works. So if my boy hits the lighthouse, he disappears, and he has. And if my girl hits the lighthouse, it's quite difficult to do because the lighthouse is moving. There we are. They've both disappeared. Lovely. So a bit involved, that one, but the next one, number 8, is actually reasonably straightforward because back in the lighthouse code, I just need to tell it to play a sound when I remove the boy or when I remove the girl. Now, the sounds for years have been in this sounds folder called pop.wav. Please do check because it could change from year to year. They've never changed it in the exam, but just in case, please do have a quick look and make sure that it is pop.wav. And if it is, or regardless of what it's called, we have one simple line of code here. Greenfoot.play sound, and then in speech marks, pop.wav, semicolon at the end. We can copy and paste that down onto our girl and compile it. Play sound, not sounds. There we go. And if we run it now, we should get a lovely pop when, there we go, when we hit the lighthouse. Now, question 9 is probably one of the most complicated things I've seen. I don't think it's complicated because of what you need to do. I think it's complicated because of the way this question has treated more than one counter. So what's happening basically is we have a counter on the left for the boy, a counter on the right for the girl. When they hit the happy face, the counter goes up. When they hit the grumpy face, the counter goes down. And when they get to the lighthouse, they get 1,000 bonus points. So let's start by setting up the counters and making sure that they're all in the right places. So we need to right click on counter and add it to the left. Right click on counter 2 and add it to the right. Save our world and then compile to make sure it's all worked perfectly. Now what we're going to do then is going to go into our code for the world, equation 11. And we just need to move 2 things out of this void method and up here into some of the space. Ideally up here to some of the space just after the curly brace that talks about the class in this white line. We're going to take the line that describes the counter, we're going to cut it from there, and we're going to paste it up here. And we're going to do the same thing with counter 2. Now you might be thinking, why on earth are you doing that? What insanity, Mr. Morgan, are you thinking about? Well, by removing it from this method, these values are accessible from other methods. And that's useful because we are about to write another method. We're going to write a method called getCounter and getCounter2 that are going to be used to return the values. Now, object orientation, which is what we're learning here, works in this way. It keeps the data separate from the methods. So you shouldn't be able to directly talk to the data, which has a number of security implications. So how do we do this? Well, I'm going to start with counter. So I'm going to say it's a public method, which means that other objects, other actors, or the worlds can talk to it. It returns a counter. Oh, dear me. Lost the ability to type there. It returns a counter, and this method is called getCounter. It has a left bracket and a right bracket there because it means there are no arguments. There's nothing to be said to it. All this is going to do, very simply, is it's going to return our counter, and that's the name of our counter here. We're going to have exactly the same bit of code again underneath, but this time for counter 2. So this returns a counter 2. We'll call it getCounter2, and it returns counter 2, this guy here. Compile that, check that's okay. Looks good to me. So what we've done is we've just made these 2 values accessible by other items. Now, we need to add a counter for the boy and the girl, so when they hit a happy fish, it goes up, a grumpy fish, it goes down, and when they get to the lighthouse, they get 1,000 bonus points. Now, I'm going to say with the lighthouse first, because we already have code in the lighthouse that describes how to interact. So what we need to do in our lighthouse is we need to introduce the lighthouse to the counter itself. So we have a boys counter and a girls counter. So I'm going to have counter equals ocean dot get counter. That's the name of our world as specified here. I'm going to have the same thing again for counter 2. So it's counter 2, counter 2, counter 2. Let's check that's okay. It's happy with it. Fine. Now we've introduced our lighthouse to the counters and we've told them what they are. We can talk to the counters from within these methods. It's always worth checking in the counter to see what they've called the method. It's usually bump count, but sometimes it's bump counter. It's always worth having a quick look to check what it is. That's the method we're going to call. So when the boy hits the lighthouse and escapes, he's going to get 1,000 points. So that means we're going to do counter, which is the boy counter, bump count, oh dear, bump count, and in brackets we're going to tell how much to increase by. So 1,000. So I'm going to copy and paste that into the girl. Just remember the girl's counter is called counter 2. And if we just check in the counter, I think the method has a different name as well. Yeah, it's bump count 2. So that also needs to have the method of bump count 2. Compile it and check it works. If I run it, if I get any of my characters to that place, there we go, and I did with my boy just then, and my girl to it as well, she should hopefully, there we go, that was the scores have increased. Okay, so we've got the lighthouse done, but we need to deal with both the happy fish and the grumpy fish. Now there are multiple ways of doing this. The easiest way, given what code we've got already, is remember what we're doing is introducing the lighthouse to a boy and a girl and adjusting their scores, is to put this code in the grumpy fish and the happy fish. So let's start with the grumpy fish. The score should go down here. After the moving code, I'm going to press enter to go into space. I'm going to put this in. Now, I don't want to delete the boy if I encounter him. I don't want to delete the girl if I encounter her, but the counter will be changed differently. It will be -1 in both cases. Same for the happy fish, but this time the happy fish we're going to increase the score. So I don't want to delete the boy if it's a happy fish, but I do want to increase the score by 1. Click compile. There we go. And now if we run it, we should have the ability for my characters to hit happy fish and increase their score. There we go. And if they hit grumpy fish, their score should go down. If I can catch a grumpy fish, there you go. So we've built the fully working game. It wasn't too difficult. We've been going for not a massive amount of time, but there were some tricky things. More than what we usually do. The counter, there were 2 of them. And because there were 2 counters, it involved a little bit more thinking about it. And actually, it's a little bit more difficult than you'd imagine it is, because this isn't a normal way of dealing with 2 counters. In the real world, what you'd have is you'd have a class called counter, and from that, you'd have a subclass called counter and counter 2, which would have the same methods and they'd inherit the same thing. So this is a bit of a poor implementation to teach you object orientation. But you know, it is what it is. It's a GCSE style question. It's meant to give you the general idea of it. So go and try that yourself. Let me know how you get on, and have a look at the other scenarios. If you want to pick up from there, the next scenario I suggest you try would be Moonbase Alpha, which has similarly 2 different counters, but gives you less of the code to get them working.